This is Pong. This is Pong, and I'm playing it directly off of a USB stick. The computer I'm using has no operating system installed, so what is Pong running on? And the answer to that is... nothing. Pong is running all by itself. Today I'm going to play 10 video games without an operating system. No Windows, no Linux, no nothing. Just games running bare metal directly on the CPU. And along the way, I'll rank all 10 of them from most fun to least fun, and explain exactly how they work. This is gaming with no OS. I'll start off with a little setup tour. I've got the Raspberry Pi keyboard hooked up to my Dell Optiplex, and I'm loading the games from this USB stick. So, operating systems. Most computers run on an operating system, whether that's Windows, Mac OS, or Linux. Every PC game you've ever played has run on top of one of those three. But have you ever stopped to wonder how many things your operating system actually does while it's running a game? So how is it possible to play a game directly on a computer, without anything running in between the game and the processor? Actually, this is how almost all video games used to be played. Many older game consoles, like the Atari 2600 or the NES, didn't have an operating system. Everything was booted directly from the game cartridge. And that's similar to what I'm doing here. Every game I'm playing in this video is being run as an IMG file, which are traditionally used for floppy disk images. To boot up the game, I can just put this USB stick in the PC, then turn the monitor on, and then turn the PC on. I'm not sure which key is the BIOS key, so I'll hit them all. I think it was F12, and this keyboard only goes to F10. I'll be right back. Alright, I've got the gaming keyboard now. I should be able to just restart this, then smash that F12 key, and look at that. I'll just boot the USB, and we're gaming. This is Breakout, which is really just a more advanced version of Pong. Based on the blinking cursor in the top left, I think this entire game is being rendered as text, which is crazy. I never was very good at Breakout, so let's give this a shot. This is pretty simple. I just use the Control and Alt keys to move the paddle back and forth. And I already lost. Nice. The funny thing about most of these games is that if you lose, you have to restart the whole computer. I can press all the keys, nothing happens. It's basically soft locked until you reload the file. I'll rank this one above Pong, because again, it's kind of the same thing but better. Anyway, let's try Space Invaders next. See this screen that's asking me which device to boot? That's a part of the BIOS. BIOS stands for Basic Input and Output System, and most computers have one. The BIOS is a piece of firmware, which is a program that sits between hardware and software. Unlike Breakout, I consider myself to be pretty good at Space Invaders. This one is a bit different from the arcade game though. I like while the enemies are multicolored. While I'm playing this, I should explain how a BIOS works. If your computer is newer, it uses something called a UEFI, which is kind of the same thing but more advanced. My PC is older, so I'll be focusing on the BIOS here. Every motherboard has a BIOS designed to support its unique hardware. The advantage of this is that an OS like Windows doesn't need to know how to start up every CPU that's ever been made. It just needs to talk to the BIOS, which gets the computer started, then hands off control to the OS. Oh gosh, these guys are getting a lot faster now. I gotta get this one over here. No! I was so close. I only had 4 left. I love Space Invaders though, so it's gonna take first place on our ranking. Next up, this game is a bit more modern. It's the dinosaur game from Google. This looks pretty cool. Okay, we're instantly dead. How the heck do you jump? There's not a single keyboard key that does anything. I've pressed all of them. The GitHub page says Shift to jump and Control to crouch, but neither of those do anything either. At least this one restarts itself, otherwise I would be doing a lot of reboots. Well, if we can't do anything with it, can it really be counted as a game? Which means the Dino game gets last place, unfortunately. I'm quite excited for this next one. It's Pac-Man! In my opinion, Pac-Man is the best arcade game. It's just an absolute classic. Leave a comment and let me know, what's your favorite arcade game? Arrow keys to move, simple enough. The ghosts are coming really fast, and there doesn't look to be any power pellets. We may be in trouble. Oh gosh, I'm stuck in the corner. I'll squeeze out the top. Yeah, no chance. We don't have to reboot the computer though. That's really nice. Why did I go that way? That was silly. Oh, I really should explain how these games are running. When you start up your computer, the BIOS lists out every device that's connected. Most bootable devices, whether that's a floppy disk, USB stick, or SSD, have a very tiny area of storage called the boot sector. This section is loaded into memory when you boot it up, and it tells the computer how to load the data on the rest of the device into RAM. However, all 10 games I'm trying in this video have all their code written entirely in the boot sector, which means that each game is 512 bytes in size, which is a tiny amount of space. To give you some perspective, Super Mario Odyssey is about 6 gigabytes, or 6 billion bytes. So every game in this video is around 11 million times smaller than Mario Odyssey. That's absolutely wild. Once the OS or program is booted, the BIOS is pretty much done working. Now, every pixel you see on screen, every key you press, and every sound the computer makes is being handled by the program. This is pretty easy for an operating system like Windows or Linux, but to fit all the code to do that into a tiny boot space, as well as fitting in all the game code and graphics, is an incredible challenge. I'll talk more about exactly how these games are made later. Oh no, I'm stuck in a corner again! Well, they got me. It was a pretty good run though. I think I'll put Pac-Man right below Space Invaders in second place. Now it's Tetris time! Alright, we are jumping right into the game. Wait, what is that? How do you turn a block? Okay, I'm just gonna let this game go. It seems like the up arrow key turns the block. Time for me to lock in and play some professional Tetris. While I'm doing that, I want to answer a question that some people might be having. Why do we even have operating systems in the first place? If programs can run without them, are they even needed? And the simple answer to that is no, not really, but it does make everything a lot easier. If there were no operating systems, every game and every program would have to know how to support every single different hardware combination, all by themselves. An operating system handles that by managing memory, loading files from storage, talking to graphics and sound drivers, and organizing CPU cycles. This results in two huge benefits. It makes programs easier to develop, because developers only have to write their program to work with the operating system, not with the hardware. And an OS also allows multiple programs to run at the same time, so that you don't have to restart your computer every time you want to switch apps. Operating systems exist because they make everything a lot easier, not because computers can't work without them. Man, I played a pretty good game of Tetris there for a while, but it really fell apart at the end. Still, Tetris is going to take first place because it's an absolute classic. We've got one more game before we get to the final three, and this one's a bit unexpected. This is Wordle, the New York Times classic. Whenever I play Wordle, I always start by guessing the word irate, because it starts you off with the three most common vowels, I, A, and E. I'd love to get the other two vowels, so nuance? Is that a word? I guess it is! Actually, they probably don't even check if the word is real. There's no chance they're able to fit a dictionary into 512 bytes of space. I'll stick with the rules though. So, radon? I cannot tell which color is which. I'll follow up with aeron. That might not be a word. I want to get at least one letter green, so I'll guess all A's. Well, I guess purple meant it wasn't even in the word, so that was a waste. How about all O's? There we go. I guess it starts with O, but we'll never know what it was. I'll rank Wordle right below Space Invaders. It's fun, but it's not quite the most fun. And now we're on to the final three. These ones are on another level. And we're starting off with one that's less of a game and more of a program. Somebody managed to fit an entire 3D ray tracing demo into 512 bytes of space. Look at this! It's crazy! We've got 3D movement, shadows, color, light, everything. And it's running pretty fast, too. Apparently, this game was originally written to run on 8-bit Atari computers, and on those, it could take 16 hours to render the whole animation cycle. Now that it's ported to x86, my PC is running it in just a few seconds. It's crazy how far hardware has come. I should probably explain how these programs actually draw graphics. This PC has no GPU installed. All of this is being calculated on the CPU. Because there's no operating system, the program has to directly handle all of the graphics. Most of these games switch the computer into VGA graphics mode, where every pixel on the screen is represented by a specific section of memory. And all that's stored in an area called a frame buffer. To draw a pixel, the game simply has to write a specific number into that pixel's spot in the RAM. By updating that thousands of times every second, the program can create moving graphics. I'll turn off the lights for dramatic effect, so I can show just how beautiful this is. Man, you guys, this is just so cool. We are ray tracing on bare metal. Yeah, this one's taking first place. We've only got 2 games to go now, so I should probably answer the question everyone's been wondering. Can it run Doom? If you're unaware, Doom is a really old first-person shooter that's known for being able to run on almost anything. People have gotten it running on iPods, receipt printers, ticket kiosks, literally everything. The original Doom took up 12 megabytes of space, which is really small by today's standards. That's 12 million bytes. Unfortunately, we only have 512 bytes to work with, which means we would have to make what is already a pretty small game 23,000 times smaller, and they've kind of managed to do just that. This is cubic Doom, and although it's missing the textures, layout, weapons, and story, it manages to fit movement, enemies, and shooting into a tiny amount of storage space. These bright colored cubes are the enemies, and they slowly move toward you and then attack you from behind. That's nice. Luckily, the game reloads itself every time you die, so you don't have to do a full reboot. You can use left shift to move forward and right shift to shoot. And I got killed from behind anyway. Lovely. This time I'm just gonna stay in the corner and shoot them before they get close to me. There's no crosshair, so I assume the shot only counts if they're in the middle of the screen. I think I might have cleared out the entire map. Wait, there's still some guys hiding back here. What? Where did that one come from? He just backstabbed me out of nowhere. I think Cubic Doom has to take the award for most fun fit into 512 bytes, unless our final game can top it. Before we get to that last game, I do want to talk a bit more about how these games are made. To fit so much into such a small space, most of these games are written in a programming language called assembly. Assembly is like code that directly controls your CPU. Once the game is all written, a program called an assembler makes the assembly code into an image, which can then be booted from a floppy disk or USB stick, which is exactly what I'm doing here. These games are incredibly hard to make, so I've made sure to link to all of the developers in the description. Make sure to check them out. Now it's time for our final game, a full roguelike fit entirely into a boot sector. The only roguelike game I really know anything about is Side Order, and I'm not sure if that really counts, so this should be interesting. The GitHub page includes a section explaining what every symbol means. Diamonds are traps, clovers are food, squares are armor, arrows are weapons, and the asterisk is gold. The goal of the game is to fight your way through each level and slowly make your way to the top. Wait, that's like the exact plot of Side Order. Maybe I know a little bit more about roguelikes than I thought. We've got a little room here. I think I'll try to explore around it. These slots must be doors. Let's see what happens if we go through one. We discover a little bridge. That's fun. This one seems to be entirely empty, so let's head to the next one. Oh yeah, I forgot to mention. The enemies in this game are represented by letters, with A being the easiest and Z being the hardest. I'm not going to fight him though, because that thing to the left of me is the ladder to the next level. The top-down style of this game kinda reminds me of Jack Bros, which is a really obscure Virtual Boy game. I've played it on the channel before, it was pretty fun. Alright, time to fight this guy here. Your health is in the bottom right, and you just tap the key and watch it go down and hope that your character can take on the enemy. And it looks like we lost because the game is frozen. I'm gonna try one more round, but I'll speed this one up a bit. I'm gonna head over to the bottom left now. No, I walked right into an E. Looks like that's game over, folks. I think this game takes the cake. Is that a phrase anymore? Do people still say that? I think this game takes the cake for the most gameplay you can fit into 512 bytes of space. You could easily spend hours exploring this place. I'll rank this game right below Doom. It probably has the most fun total, but Doom feels more fun because it squeezes all the fun into a smaller amount of space. Which means that Cubic Doom takes the award for the most fun you can have in 512 bytes of space. Well, that's all 10 games, which means that we can answer the question once and for all. You don't need an operating system to have fun playing games, because, as we've seen today, there's tons of fun to be had in just a few bytes of space. Again, I've put links to all of these games in the description, and you should totally go try them on your own computer. It will be a ton of fun, I promise. Well, now that the video's over, you probably want to go watch something else. But since you watched all the way to the end, you probably liked my video style. So I put 2 more of my videos on the screen that you'll probably enjoy as well. Anyway, that's all for me. I hope you have a really good day.